Good morning, Madam President. Madam President, good morning.
Hello, Dr. Fashino. Good morning.
Good morning, Dr.
President.
Oluwatoyin. Good morning. Yeah, President is on the call too. Good morning, Madam
Yes.
President.
So, you're in charge, sir. You're on
No
a trip.
problem.
I'll be seeing all your messages.
No problem.
Good morning. Oh, sorry. I was not too close to my computer. Oh, no.
Oh, Madam
The
President,
editor.
good morning.
Good morning. Incoming. Well done. You're doing well. So I'm just surprised though. People are not on this call yet.
I was equally surprised too.
Please, let's put it on department. Your surgery, put it there. Let me put it on my own. Maybe
Okay,
people are
no
not
problem.
checking the platform. Madam Editor, please call your people. Thank you.
Good morning. All right, good morning, sirs and Mars. We will be starting soon. Kindly encourage members in your unit to sign up and join in on the call so that we can start in earnest. Chat people up, speak to people one on one so that they can join in on the call. Do not intend to waste people's time. We intend to start as soon as we can. All right, thank you very much. Good morning, sirs and Mars. We decided to start by 9:05 a.m. to give people more time to join in. However, once it's 9:05 a.m., we're going to start promptly. Recognize the presence of the DCST who in his usual manner is already here with us. Thank you very much, sir. Please reach out to people, colleagues in your departments, chat, let them join in so they don't miss out on very cool and important discussions. early in the sessions. Thank you. All right, just one more minute to go. Please inform people. Again, encourage them to join in. We're starting by 9:05 a.m. I would like to welcome and recognize the presence of the president of the Association of Resident Doctors LASUTH chapter, Dr. C. You're welcome, and all that at schools who have also joined in. Thank you very much. Please once again join me and encourage others to do so, so that we can everyone can be carried along from the beginning. All right, thank you very much. It's now 9:05 a.m. and we're going to be starting the program promptly. Um, Good morning, SARS and Mars. Good morning, Nigeria. Good morning, Lagos. Good morning, LASUTH. My name is Dr. Fashion, aka Dr. Fashion. I'll be your anchor for today. I welcome every one of us to the fourth quarter academic research forum. It's a quarterly research forum organized by the editorial unit of LASUTH-ARD alongside the executive body of LASUTH-ARD. So far, we've had 3 editions this year covering various aspects of research, covered by seasoned researchers, mentors, and teachers. Today's edition is titled Statistical Analysis in Research. I'm privileged to have the esteemed Professor Adino with us to share with us. Again, please encourage people to join. They can't afford to miss out on this. It's going to be a fun time where we learn. Please invite others to join in. And to add, there will be a giveaway sometime during the program, and that will be announced soon. So I encourage people to join in. All right. Like I earlier recognized, I want to recognize the presence of the DCST, Sir Adebowale Adekoya, who, like I mentioned earlier, in his usual practice, usually joins early in the program, a model of time keeping to time. Thank you very much, sir. I also welcome the president of the association and all other clear schools who have joined hands together to make this program a possibility. Without further ado, I would want to recognize or welcome the president of the leading ALD chapter in the country, the LASUTH ALD. We call her Madam President, but for formal purposes, I welcome Dr. Morolayo Onyeisi for our welcome speech. Thank you.
Thank you very much, Dr. Fashino. I would like to start by saying good morning to our distinguished and ever-present and punctual Director of Clinical Services and Training, Professor Adebowale Adekoya. I would also like to extend our special greetings to our guest speaker for today, our professor and consultant in community medicine here in LASUCOM and LASUTH, Professor Adeyinka Adeniro, and as well as our ECLAT executive committee members and all distinguished members of LASUTH-ARD, as well as NADITEs who might be on this call and our special guests too who are present with us this morning. I would like to once again welcome everyone to the last quarter, that is the fourth quarter LASUTH-ARD Academic Research Forum. Truly, it has been a remarkable year. Just like the anchor earlier said, we started in the first quarter talking about overview of research methodology and publications of scientific papers. Then we went into the second quarter to, go deeper into research methodology. And in the third quarter, we extensively discussed literature review. And now, finally, to wrap up this quarter, we are going to be discussing statistical analysis, which we can all agree is one of the very rigorous aspects of research or research methodology. So I know I may not get another chance to speak on this call, so I would like to also take this moment to sincerely appreciate all efforts of the editorial team, ably led by Madam Editor, on ensuring, timely, effective, meaningful, relevant topics were discussed in this tenure. And I also want to appreciate the ECLAT Executive Committee members for their commitment to academic and professional excellence. And of course, I can't forget to appreciate the Congress as well for, always being very active participants in all these sessions. And I hope that we have all learned or we've been able to pick one or two things. Again, today we have Professor Adeyinka in our midst, who is very renowned in the field and with a lot of publications. So we have a lot of wealth, we have wealth of knowledge to tap into. And I'd like to encourage us to get our pen and our paper in our usual fashion. Maybe we'll add calculator and software and statistical software today. And let's have an engaging session. Let's ask questions. And on that note, once again, I would like to say thank you all for giving me this opportunity to lead the association and have a wonderful session today. Thank you.
Thank you very much, Madam President, for that brief but concise welcome speech. We will now proceed to the DCST's welcome speech. But before I do that, permit me to especially welcome and recognize our speaker for today, Professor Adeyinka Adeniran. Thank you very much, sir, for giving us time out of a busy schedule to be a blessing to us today. Thank you very much, sir. We'll now proceed to the DCST's welcome speech. We kindly welcome Professor Adeboale Adekoya for his welcome speech. You're welcome, sir.
Thank you very much. Can you please confirm that I'm loud and clear?
Yes, you are, sir.
Okay, so let me just quickly follow up with what our Madam President just said about the consistency of this program. I agree completely that it's been consistent, and far above that, it's been impactful. And I think it's a big plus that she and our ESCO members, other ESCO members will take away as they exit soon. I want to congratulate you. I want also congratulate as many who probably must have worked with you from behind the scene for carefully selecting the speaker, because today you have an eminent speaker, Professor Adeniran. He is not just the right fit. He is someone I can guarantee you will deliver in a special way on this topic, statistical analysis in research. And also, like I do normally, to not boast, but say the obvious, that at LASUTH, in terms of training, we continue to be in forefront. Our residents have now owned and earned success as trademark. It's no news that someone goes for exam from LASUTH and passes. It becomes big news if that person, for some very unlikely reason, fails, meaning that the training here has been uplifted to the level where success is now a must. And part of that, the glory, must surely be shared by all of the ESCOs before MKO and ourselves and our members. We want to continue to encourage you to not just showcase what LASUTH represents, but also to continue to have great hope in yourselves. We're always happy to let the whole world know that we're not running residency program in LASUTH because we just want to tick the box, but because we know that we can do this to teach others how it can be done better. And this, the ever dynamic CMD of the hospital, Professor Adetokunbo Fabanwo, has consistently showcased in all of the things pertaining to training, in terms of your welfare, in terms of making sure like event like this receive the best of encouragement, and in terms of making sure that even when you leave, we're able to reabsorb the very good ones from amongst you. It's not a time for too much of talks. We all want to sit back and enjoy the dynamic professor take us through and talk us through statistical analysis and research. I once again congratulate Morala Okikelomo on Nomusi and ESCO, even as about soon, and also to continue to wish them well as they make progress in their chosen career. Thank you and God bless.
Thank you very much, sir, for that inspiring welcome speech. It's always a privilege to have you join us, sir. And like I said, we always learn from your keeping to time in terms of logging in and joining us earlier enough. Thank you very much, sir. We will now be proceeding to the citation of the speaker. Before we do that, I did mention that there will be a giveaway just to encourage us and appreciate us for joining. So here's what we're going to do as the fastest finger first. We've had 3 editions of this program this year so far. So kindly just put the 3 topics that have been addressed in the chat box. The first person to correctly get the 3 topics in a chronological order has the cash gift that is courtesy of the editorial unit. So feel free to leave your messages in the chat box. All right, without further ado, we'll now be taking the citation of our speaker for today. I call on Dr. Obasonya to please take the citation of our guest speaker today.
Good morning, my teachers on call, senior colleagues and colleagues. Standing on existing protocol, it's an honor to read the citation of my teacher, Professor is an accomplished professor of community medicine at the Lagos State University College of Medicine, LASUCOM, and teaching hospital LASUTH. His academic journey began at the University of Ilorin, where he obtained his MBBS in medicine and surgery in the year 2003. He further specialized in public health, earning an MSc from the University of Lagos in year National Postgraduate Medical College of Nigeria, and is a member of the West African College of Physicians, both year 2011 and 2008 respectively. He completed his certificate course in healthcare financing from the Institute of Public Health, University of Edinburgh, Germany. Professor Adeniran's research interests are deeply rooted in critical issues facing healthcare systems in developing countries. His primary focus is on improving access to quality healthcare while protecting its users. Professor Adeniran has made significant contribution to public health research and practice. He has authored or co-authored in over 60 peer-reviewed journal articles. In addition to his research, Professor Adeniran has taken on important leadership roles within Lagos State University. He served as the acting head of Department of Community Health and Primary Care from year 2020 to year 2022, and was a member of the University Senate. He also sits on the Lagos State University Health Board, demonstrating his commitment to improving healthcare at an institutional level. Professor Adeniran's expertise extends to postgraduate education, where he supervises dissertation and coordinates multiple postgraduate programs in the university. Collaboratively, Professor Adeniran has since 2010 provided health system management advisory and strategic support to several organizations, including International Health Management Systems, Family Health International, Hope Worldwide, MTN Nigeria, GT Bank, Topanga Nigeria, the Lagos State Government and the Kaduna State Government, also the Philip Consulting and the Federal Government of Nigeria, among many others. Professor Deniro regularly presents his research at national and international conferences, contributing to discussion on universal health coverage, infectious disease outbreaks, and health system strengthening in Nigeria. His work has been recognized with awards, including the Dr. Peter Odili Prize for the best research project in health management from the National Postgraduate Medical College of Nigeria in the year 2011. As a consultant and public health expert, Professor Adeniran bridges the gap between academic research and practical implementation of health policies. His work consistently aims to improve healthcare access, quality, and finance in Nigeria, with a particular emphasis on strengthening primary healthcare system through his research, training, and leadership. Professor Adeniran continues to make significant contributions to the public health space in Nigeria and beyond. Thank you. This is the brief citation. Thank you so much. Over.
Thank you very much, Dr. Abasaria, for that wonderful citation. Can we then welcome with a round of applause our guest speaker for today? You're welcome, sir.
Thank you, thank you, thank you so much. Good morning, ladies and gentlemen. I want you to confirm that I'm audible before I proceed.
Yes, you are, sir.
Great. Thank you so much. So good morning, ladies and gentlemen. Let me use this opportunity to recognize our DCSC, Professor Adebowale Adekoya. Good morning, sir. And I also recognize the ESCO of LASUTH-ARD, ably led by Morolayo. Thank you so much for inviting me this morning. So that we'll not waste so much time, let me just quickly go ahead and share my screen. And so please confirm that my screen is also visible. Can you see my screen?
Yes, it is visible, sir.
Oh, great. Okay, great. All right. So this morning we'll be looking at statistical analysis in health research. Okay, because when we talk about statistical analysis, usually we look at the practicality of it. But you must have the basic theoretical understanding before you can even move ahead to really practicalize anything. And in fact, sometimes that theoretical understanding is even the 80% that is very important, because sometimes you may not even be the one to really conduct the analysis. But it's extremely important that every researcher must have the theoretical background or the theoretical knowledge of how statistical analysis works. So the objective of this lecture is to equip all the participants with the foundational knowledge, basically, to be able to select, apply, and interpret appropriate statistical method for health and medical research data analysis. And by the end of this lecture, you will be able to understand core statistical concepts and terminologies, perform data management and basic descriptive analysis, conduct hypothesis testing with appropriate statistical method, interpret results from common inferential statistics, and select the right statistical test for different research questions. And I'm very happy that you have done a bit of research methodology. So this is just going to be like an icing on the cake for you guys. And I also want to assume that most of us are not really new to research. Yes, we may have some junior residents that have not really been participating a lot in research work, but I'm not sure they are completely new, because I know that at undergraduate level, you are expected to conduct a research before you can badge your MBBS, so we are not completely new. So, but we will take it a bit deeper and then expand it a bit as well, so that at postgraduate level, we'll be able to apply, some of this knowledge accordingly. So I'll follow the following outline. So at the end of the day, we just treat most of the concept, so that you have a basic understanding, of the concept and how to apply it in your research endeavors. So the first thing is everything is about research. Okay, so we want to look at what exactly is research. So it is a systematic, controlled, and empirical investigation of natural phenomena, and it is guided by theory and hypothesis. So what we are just saying is that it has to be systematic. So there is a way to go about it, and it is very controlled, and it is fact-based. So you have to collect data, okay, to investigate data on whatever you want to investigate. And it has to be guided by theories. It has to be guided by hypotheses, and to be able to generate a new knowledge. So basically we have a lot of questions which we call research questions. Those questions, they are knowledge gaps. Okay, so we want to find an answer. So for example, before now, we're looking at, okay, what are the risk factors for maybe COVID-19, or maybe for malaria, or maybe for hypertension. So those are questions. Okay, and then it is through scientific research that we find answers to those questions. So there are quite a lot of components of empirical research that you must be familiar with. But one of the components which we're going to be talking about today is the data analysis component, because everything is centered around the data. Interestingly, you have addressed most of these other components earlier in the year, based on what the president said, that you've taken some topics earlier in the year. So I believe that you have addressed some of the components. So the focus of today's work is basically on data analysis. So when we talk about statistics, what exactly do we mean? What is the meaning of statistics, or what is statistics? So statistics is basically a science of data collection, organization, analysis, and interpretation. So statistics is all about data collection. So how do you go about collecting the data? How do you organize the data? How do you analyze the data? And what is the interpretation from your analysis? That is what statistics is all about. And when we now come down to biostatistics, or what some people call medical statistics, so we are basically talking about the application of statistics to medicine and public health. Okay, so how we use the concept of statistics in medicine and public health. So that's basically what biostatistics is all about. And it is very important, especially for healthcare professionals, to understand and interpret complex data. So they need to understand statistics if they will be able to deal with data. Like I normally tell our colleagues, that we are sitting on a gold mine, which is data. Even though those data, they are not properly organized, which is part of, what we should do as professionals, to see how we can organize that data and bring up knowledge, or bring out knowledge from those data. So those data will help us to understand, even within the hospital setting, a lot of data that we generate on a daily basis, a lot of data, so those data, they are important for, evidence-based decision making, improving patient outcome. So if we're able to harness those data properly, we'll be able to achieve a lot in terms of improvement in our system, looking at operational improvement, and then the overall quality of health of our patient. So globally, when you look at application of statistics, of course, you can't conduct any clinical trials without, statistical analysis. You can't propose any public health intervention without, research, which at the cornerstone of it is statistics, disease surveillance, evidence-based medicine. So these are some of the applications of statistics in medicine and public health. So when you hear the word statistics, we can look at statistics in two ways, okay? You can look at statistics as whether it is descriptive statistics or inferential statistics. Remember, I said that statistics is basically a systematic way of collecting data, organizing data, summarizing data, analyzing data, and interpretation of data. So you can have two types of statistics, whether descriptive, just to describe your data distribution, or you have what we call inferential statistics. That's where you go into the realm of generalization. So you now want to make an extrapolation based on your result. Or you can also look at statistics as whether it is parametric statistics or non parametric statistics. Most of what we do in the health sector is parametric statistics. So we're not really going to be talking about non parametric statistics that much, but we'll also mention it, for your information. So descriptive versus inferential statistics. That's the first aspect of, that will be the first aspect of our discussion. We're going to look at what are descriptive statistics and what are inferential statistics. Like I said, descriptive statistics just summarizes the sample at hand without claiming any universality, while inferential statistics try to make conclusion about the larger population based on the result. So in the realm of inferential statistics, that's where we talk about p-values, confidence interval, regression coefficient, risk ratio, hypothesis testings, and those kind of things. While in the realm of descriptive statistics, we just look at the distribution of data, maybe in terms of mean, mode, median, that's measures of central tendency, or standard deviation range, interquartile range, the frequency distribution, charts, all those kind of things. Those are just basic description of your data. So it's good to have this understanding. For most of us, we're actually going to be doing the two for our work or in our work. So you're going to be conducting a lot of descriptive statistics, and you're also going to be doing a lot of inferential statistics. Now, I said statistics is about data collection. At the center of statistics is data. So we need to understand what exactly is data. What is data? How do we measure data? How do we measure variables? What are the scales, of measurement? And how do we present data? Okay, so I just have a few slides I know it's something that we are familiar with, just to remind us of what exactly we mean when we say data. Okay, and when we say data, we are not talking about the data that most people use every day, internet data and all of that. We are talking about raw facts that we get when we measure variables. So raw facts or figures or measurement collected during a research study. Okay, it can be during a research study. This is more like a primary data, but you can also have secondary data. Okay, so during a survey, you collect primary data. Those are the ones you collect by yourself. But you can have secondary data, which can be internal or external. Okay, so secondary data like hospital records and the rest, those are also data. They are raw facts. They're just there. Okay, you can't really make anything out of it until it is properly analyzed. And we have two types of this data. We have what we call numerical data, and qualitative data and categorical data. So numerical data is also known as quantitative data. Those are data that can be counted or measured. Categorical data, they describe qualities or categories. Okay, so for example, your blood type, gender, you have male and female. Blood type, you have maybe O, B, A, so different groups, different categories. So just look at categorical data, putting people in different data quality in different categories, while numerical data counts or measured data. For categorical data, you can have discrete, those are data without decimal numbers, or continuous. While for, sorry, that's for numerical data. For categorical data, you can have what we call nominal data. So those are data without any order, or ordinal data, ordinal categorical data. Those are data with order. It's just to remind us. And then when we want to measure, when we want to collect this data, there are four major scales of measurement that we have, that you have to be familiar with. So when we say scale of measurement, because in research, you are actually measuring. So even if you say, okay, what is your age? That's a measurement. Okay, it's like that kind of measurement. You are not now using an equipment to do that. Okay, you are maybe if it is self-administered, your tool is the measuring tool. If it is interviewer administered, the interviewer is the one that is now measuring it. Okay, so so those are measured. Everything that we collect in terms of data in health research, we collect via measurement. So you have to understand the scale of these measurements. And then we have four of them, four scales. Nominal, ordinal, interval, and ratio scales. Now, I'm going to be talking a lot about different concepts in statistics, which most of you might be familiar with in one way or the other, or may not have that understanding maybe, or it will just have like a reminder to some people, why it may be new to some other people. But just take note so that if there are questions, because I know we may not be at different levels of knowledge as far as statistics is concerned, so that if we have questions, please just take note, and then so that when we are at the question and answer level, we'll be able to attend to that. But let me confirm from the coordinator, I hope I'm working with 2 hours lecture. Is that correct? Dr. Fashina, I have 2 hours, is that correct?
That's correct, sir.
Great. All right. So just to confirm.
Yes, sir, that's correct, sir.
Yeah. So we have nominal, we have ordinal. Nominal categories with no inherent order. So if there cannot be order to the categorical data, that is a nominal data. Like gender, there is no order. Ethnicity, no order. Religion, no order. Blood type, no order. So that's a nominal data. Okay. Ordinal is also a categorical data, but in this case, they have order. Now, but they are ordered, but they have unequal distances in terms of distance between the different categories. So for example, if it's a cancer stage 1, stage 2, stage 3, stage 4. Okay. Yeah. So yes, there is order. Okay. That makes it an ordinal data or an ordinal variable. But if you look at stage 1, stage 2, stage 3, stage 4, you can't say there is an equal distance between each of those categories. So that's what makes it an ordinal data. So we use ordinal scale at that level for measurement. Interval scale is used for numerical data. So this time is numerical data with known differences, but no true zero value. Okay, so if you look at a very classic example is temperature. So if you look at temperature, they say 38 degree or 36 degree centigrade, okay, or 37 degree centigrade. Yes, we can see that they have differences. There are differences between 35, 36, 37. But you can't say you have a 0 degree centigrade. You know, that's so if you say, I'm talking about temperature, body temperature now. Yeah, if you say it's 0 degree centigrade, that measurement doesn't have true zero. So that measurement does not have true zero value. That's true absolute zero. And then the other thing is, if we say something is 35 degrees Celsius, yeah, Celsius. Okay, I hope it's not from my end. So you say 30. So if you say 30, let's say 36 degrees Celsius, and then we say we want to divide it by 2, that maybe the half of that temperature will be 6 degrees Celsius. I think we are having background noise from the other side. So maybe if we can have people mute their mic, that would be fine. Okay, so you can say, okay, 36, and then you now come to, okay, half of that is 16. Okay, it doesn't work like that for temperature. You can't say, the person is half, is as half, how will I put it now? Temperate. The half is 16, and then the person is 36. So that scale cannot have a true zero, and then you can't quantify in terms of you can't quantify, you can't multiply the quantity, to be able to get, okay, we have twice the temperature or 3 times the temperature, or this time is twice colder and things like that. So because of that scale, so that's interval scale. Where you can have that kind of thing is in the ratio scale, where there is a true absolute zero. So it's good to have this understanding, because when you are measuring anything in biomedical science, okay, it's good to know which scale are you using, because that understanding will help you with the statistical analysis. Okay, so for example, if I'm using a nominal scale, the way I will analyze data collected via that scale will be completely different from if I'm using a ratio scale. The way I'm going to analyze that is also completely different. So that understanding, when you are measuring your variable, when you are collecting your data, you must understand the type of data that you are collecting and the type of scale that you are using to collect that data. So if you look at ordinal scales, if you look at nominal, ordinal, interval, ratio scale, they all indicate differences, all of them. Okay. The nominal scale doesn't really indicate any direction of difference, but ordinal, you can see direction of difference. Okay, grade 1, grade 2, grade 3. Okay, so you can see that direction. Interval, the same thing. It can go higher or lower. And ratio, the same thing. And then when you now look at amount of difference, okay, nominal, ordinal, you cannot have an amount where you talk about the difference. But for interval and ratio, you can have the amount of difference. Okay, you can calculate the amount of difference. But when you now look at whether that amount, we can have an absolute is zero. For interval scale, you can't do that. But for ratio scale, you can have an absolute A7. So this is the hierarchy of variable measurement of scale, in research, and it's important for us to understand it. Okay. So that is data types, different types of data, numerical, categorical, and then the scale of measurement. Okay. Now, data can also be presented. You can look at how to best present your data. Yes, it's part of analysis, but that's the most basic part of analysis. But there are also principles. There are also principles to it. So, for example, the way you present categorical data is completely. Yeah, the way we present categorical data is completely different from the way we present numerical data. You have to understand that. Of course, so even when we are presenting them in a tabular format, there are ways by which we present. For example, categorical data, that's where you have frequency tables, you have contingency table, your 2x2 tables. Whereas in numerical data, that's where you have your summary table, where you have your mean, standard deviation, range, and things like that, and all the statistics. So if you are putting them in a table, and when you are looking at graphs, okay, categorical data is what you can present as as bar charts, pie charts, stack bar charts. Thank you. Stack bar charts, and so on and so forth. While numerical data is what you can present as histogram, box chart, and scatter diagram, and things like that. Now, the point of this slide is that there are principles to even data presentation. Okay, so there are principles to it. So, for example, if I'm presenting to a scientific audience, okay, so many people will just flog the whatever with charts. That's not the best way when you are looking at scientific audience. Okay, they want to see your facts, they want to see the tables, they want to see all the information in your tables. Okay, so I will have minimal charts. If I'm presenting to policy makers, yes, I can have visuals, a lot of visuals, and then very limited tables. Okay, so they want to see the pictures, they want to see which one is more, which one is less, why are we taking this decision, and so on and so forth. So you have to look at your audience. Okay, that's one. Number two, even when you are looking at, let me give you an example. So, for example, if I want to present what do you call it now? State of origin. State of origin is, what type of variable is state of origin? Sorry. Sorry, I want us to be following one another, so that I will not just be talking and talking and talking for 2 hours without getting some kind of feedback. So just someone can just type, let's use the chat box so that we can interact a bit. Okay, so what type of variable is state of origin? So I would like somebody to just type it on the chat box. What type of variable is, okay? So Chidinma said it's categorical variable. Yeah, that's correct. Yeah, somebody said it's nominal variable. So that's more specific. So that person that said it's nominal variable is more specific. So that person will get the full mark. While the person that said it's categorical variable will not get the full mark because it's nominal in the sense that it has no order. Now, the point I'm trying to make is that that is a categorical variable. So between using bar charts and pie charts, which is best in presenting state of origin? State of origin, which is best? Bar chart, or which is better? Bar chart or pie charts? Which is better to present state of origin? Which is better, bar chart or, okay, somebody said bar charts. Okay, thank you, bar chart. So that's correct. Victor Adewale also bar chart. So that's correct. So it's bar chart. Anytime you have more than 6 categories, okay, in a data, when the data has more than 6 categories, it's not good to use pie chart. Pie chart is 6 or less categories. So for example, maybe if you want to present geopolitical zones, male, female, level of education, non-primary, secondary, tertiary, those are 4 categories. So anything more than 6 categories, we don't use pie chart. So it's extremely important to understand this. While for numerical data, you have histogram, box plot, scatter plot, and so on and so forth. I'm not going to go so much into this. It's just for us to know and have that understanding that when you are presenting your data, so for example, this is a categorical data, and this is a frequency table, okay? So this is a good way to present this data, but you can also present it in a graphical format. Okay, 1, 2, 3, 4, 5, 6. Yeah, you have 6 categories there, and I'm presenting it as a bar chart, which is appropriate. So I can present it as a bar chart. I can also present it as a pie chart. Okay, it's 6. Once it's getting more than 6, you don't present as a bar chart. And when you are presenting, I always recommend this kind of presentation without 3-dimensional effect. You see some work, they present it like this with three-dimensional whatever. In scientific work, you have to be as simple as possible and as straightforward as possible. You don't bring all kinds of nuances into your work, okay? So you have to be very, very straightforward, okay? So so that I'm sure we are on the same page, I would like people to chat on the put the on the chat box what type of variables are these. What type of variable? 1, length of service. What type of variable is that? 2, staff grade. 3, age. 4, salary. 5, number of patients seen in a day. And 6, possession of a degree. So what types of variables are those? So let's see the chat box. So 1, what type of variable is 1? Okay. So length of service, somebody said categorical. Is that correct? Length of service, is that a categorical variable? Yusuf said continuous. Length of service. No, it's not continuous. Continuous has decimal. Length of service, 2 years, 3 years, 4 years. So it's discrete. It's a discrete variable. So that's what Ifeanyi said, discrete. So Yusuf also said discrete. Out of number 2. Number 2 is staff grade. Staff grade is what? So staff grade is, yes, is ordinal. Amanda Dufowa is ordinal. Staff grade is ordinal. It's a categorical variable and is ordinal. Age is continuous. Yes, age can be continuous since they said age continuous. But if I said age as at last birthday, so that would be discrete. Okay. Salary is continuous. Yeah. Number of patients is discrete. And possession of a degree is yes or no, which is nominal. So that's correct. Yeah, so it's nominal. So I believe that we have basic understanding of what we mean for different types of data, and you should be able to typify any form of data that you have. Okay. So let's move further. Any question so far? Any question? Please, if you have any question, just type it on the chat box. That's if you have any question now. You want me to address anything. So just put it on the chat box. Okay. Now, so the next thing we want to look at, okay, is you have collected this data. You've understood the data. What is the first thing you have to look at? Okay. And that's talking about your descriptive statistics now. Okay. Descriptive statistics, we have basically different measures there, measure of central tendency and measure of dispersion. To summarize the distribution of your data. So there are key things. I will just, because I don't want to believe that we all have the same level of understanding, so I will just rush through it, so that if people have questions, we can attend. So the measure of central tendency, we have basically three things to measure. It is just like a measure to tell us, okay, a typical value in this data. What is a typical value in this data? And it's basically looking at numerical data. Okay, basically. Okay, of course, your mode can look at categorical data. Okay, so median is the arithmetic average. Okay, the mean is the arithmetic average. So that's the mean. And the mean will always go with your standard deviation. That's the measure of dispersion. So there must be a match between the centrality with dispersion, always. So when you give us your mean, you must also give us the standard deviation of that data distribution. And mean is the most useful, important average for a numerical data. Okay, so mean is the most. So when you are looking at age, blood pressure, BMI, weight, height, cholesterol level, whatever numerical data, and then you want to have the average. Mean is your best bet. But there are times that you cannot use mean. When the data does not follow a normal distribution, or you have outliers within the data, then you cannot use the mean. So at that point, you have to use the median. Okay, so median is the middle value and mode is the most frequent value. Okay, so I'm not going to go into all of this because I just want us to have the understanding. Okay, so the point I just want to say here is that mean is sensitive to the influence of extreme values. You have to understand that once you have extreme values in your data distribution, you can no longer use the mean, except you trim the data. So there's a way you can trim the data for you to still be able to use the mean. Okay, but once you cannot do anything about the data, then you can't use the mean as the average. So because it's very, very sensitive to outliers. So best used for making predictions when a distribution is more or less normal or symmetrical. Okay, so that's one thing you have to note about your mean. For median, so median is also the 50th percentile. So it's also like the average. Okay, so half of the scores, the value at the 50th percentile is your median. And the median is not sensitive to outliers. Okay, so that's the only thing I want to say there. So the median is what you use when your data, numerical data, has a lot of outliers or does not follow the normal distribution. So median is what to use. I won't waste time. I won't talk more about how to compute the median because I believe the understanding is what is extremely important. So, but to buttress my point on the impact of extreme values, on the extreme values on data distribution. So if you look at this data, this first data, 85, 87, 89, 91, 98, 100. Okay, so you will notice that we don't have a lot of extreme values in this data distribution. Okay, and so the mean and the median, they are very close to one another. They are very, very close. So for example, the mean here is 91.6 and the median is 90. So that data distribution follows a normal distribution. Okay, so you don't have extreme values. Now, look at the second set of data. Okay, you have 87, 80,
It's 10 o'clock.
89, 91, 98, 100. You now have 5. Okay, you now have 5. That's an extreme value. Okay, in that distribution, in that data distribution. So because of that, now look at the mean. The mean has now been drawn down to 98.3. Okay, just because of these 5. If you remove these 5, like what we said, if you say, okay, you want to trim the data, you will still have a mean around 90. Okay, but because of these 5, if we still leave these 5 in that data set, the mean has now come down to 78.3. So this is not a true reflection. So in this case, we cannot use the mean as the average. You can see median is still 90. Median was not or is not affected by these extreme values because it's the middle value after you sort the data set, accordingly. Okay, so the median is still 90. So in this case, median is what is now going to be average. So this is just to prove to you that once you have extreme values or your data does not follow normal distribution, you can no longer bank on the mean. Okay, so this is extremely important. The mode, the most typical value. Okay, you can use it both for categorical data and numerical data. That's if you have what they call it now, a small number. So maybe a very small number of numerical data. We can have it, you can use it, but generally it's used for categorical data. And you can have unimodal, bimodal, multimodal distribution, within your data. So also is not really that useful beyond descriptive statistics when you are looking at further utility of statistics. Mode is not that useful beyond. But mean and median, they are still very useful in inferential statistics, and you are going to see how going forward. So these are your measures of central tendency, which I believe most of you are familiar with. Okay, but it's good to just remind ourselves, of the usage. That's just what I'm talking about. The usage. How do you use them? Okay, that's the most important thing we are looking at now. So it's good that we all talk about that. What of measures of central tendency? So anytime you are presenting a data or a measure of anytime you are presenting a measure of central tendency, you must also present the relevant measures of variability or measures of dispersion with it. Okay, so for example, we talk about standard deviation, variance, and range as a measure of variability. Okay, what are standard deviation? So what are measures of this variability? It's just talking about the spread, how spread, um, how far away are the data distribution, are the values within the data distribution, how far away are they from one another? So that's just what we are talking about. And why is this important? Okay, this is important because, at the end of the day, you are looking at a representative value in terms of maybe mean or the median or the most. So if we have a data set now, you have a data set of a data set for blood pressure. Okay, the most useful value in that data set is what is the average blood pressure for this data among this population. So we want to get the average. What is the average systolic blood pressure? What's the average diastolic blood pressure? That is your measure of central tendency. That's one value that will represent the other set. But that measure is not enough. That one value is not enough because we want to see whether that one value is truly representative or not. And how will you know whether it is truly representative or not is how spread apart are other values, how far away are other values to this value that we are using to represent the data set. I'm sure you understand, you get an idea of what I'm trying to say there. So how deviate, okay? How different are the other values from this value that is representing? So that's what we need. We also need that understanding to be sure that this value that is representing the data set is truly a good measure of the data set. So let me ask you a question. Also put it in the chat box. Between this, the first distribution and the second distribution, which one has a higher variability? Let's put it that way. Okay, I think the thing is there already. Okay, I'm not sure it's there. Okay, so which one has a higher variability and which one is better when you talk about research? Which one is better in terms of, as a researcher, which one would you say is better? Is better in terms of giving you a better result or giving you a better outcome for your research? Is it the first or the second? Which one, the first question is which one has a higher variability? And then which one is better? So the first, so someone said better variability, option one, better outcome, option two. That's what Bosola said. Yusuf said first in variability, the second is better. So you got the idea now. So the higher the variability, the worse in terms of your expectation. So when you have higher variability, so this one has a higher variability, that's higher standard deviation, higher range, higher interquartile range, higher any of those values when they are high, that's not what you are looking for. That's not the best for you. The closer they are to the center, the better. Okay, because you want your standard deviation to be very close to the center as much as possible. Okay, so the lower the variability, the better your results. The higher the variability, the worse your results. So just take note of that. So when you conduct your work, when you conduct your research and you are analyzing it, and you look at your mean, and you look at your standard deviation very, very high, then you know that there is something wrong with the data. So most likely you may not want to use mean, because even the standard deviation itself will tell you that your data distribution is, they are too far away from one another. Okay. Because of time, I will skip several things, especially all the calculations. So I just want us to understand the concepts, and then we can make progress. And then we have the quantiles. So the quantile splits other data into 4 quarters. Okay, it's not like, okay, it's also like the median. Median is like the 50 percentile. And then we now have quantiles in terms of distribution now, measures of dispersion. So 25, it splits and other data into 4 quarters. Okay, so position of the I quantile, that's the position point. So for example, the first quantile is at 25%, the second quantile is at 50%, the third quantile is at 75%, and then the last quantile is at 100%. So it's just this split your data set after they have been ordered into 4. So why is it important? Why is the quantile important? It's also a measure of dispersion. Okay, it's a measure of dispersion. So, for example, third quantile minus 1 quantile is how far away are the data, to the median. Okay, so when we are presenting our median, it's always also good to put the interquartile range. Okay, how far away are the other values from the median? Okay, so that's basically what interquartile range is telling us. So anytime you are putting your median, you must also put the interquartile range. Okay, so these are the measures of dispersion: standard deviation, range, and then interquartile range. Of course, from the standard deviation, you can look at the variance, but we normally look at standard deviation so that we'll not have, we'll remove the unit. Okay, so we are really getting to the meat of the lecture. Any questions so far? Please, if there is any question so far, let me know. Okay, or maybe when we get to question and answer time. So inferential statistics.
Hello, sir. I was pointing out that we have a question and answer session after.
Okay, so we should wait till question and answer time.
Yes, sir. Preferably, sir. Except
Okay,
you have
good.
your work perfect, sir.
Okay, so please just take note of all the questions, and then we will attend to them. So let me just make progress. So inferential statistics, this is where most people actually get lost, in terms of testing of your hypothesis, the statistical test that you're supposed to use to, test your hypothesis, some of those advanced, what are the criteria, what are the assumptions, and so on and so forth. A whole lot of people get confused when it comes to inferential statistics. So I will slow down a bit here so that we can really follow. So research is about trying to make valid inferences. So the goal of research is not descriptive statistics, just to describe your data. That's not the goal. It's a waste of money if you don't have what we call external validity to your research. External validity means that the outcome, I'm sure they will have told you during your research methods, your result is applicable as an external validity. It can apply to the general population, the population from which your sample was drawn. Okay, so that's the goal of research. Anything that you are doing that does not have that external validity is a waste of resources, except maybe it's just a pilot. So if it is just a pilot study, okay, yes, we can just do it to understand just as a pilot so that it will now help us to know how to go about conducting the main study. So inferential statistics is that part of statistics that allows the researchers to generalize their findings beyond data collected. Okay, so statistical inference is a procedure for making inferences or generalization about a larger population from a sample from which you draw the sample of that population. So look at this example now. So if you say the prevalence of diabetes among adults in Nigeria is 5.8%, okay, and then 5% confidence interval, 4.3 to 7.1%. So we see all these kind of statistics, in journals, in different papers when you are reading. So how were they able to make this conclusion? Okay, is because they are making a difference. It's not as if they studied all adults with diabetes, all adults in Nigeria to now know the ones that are diabetes or not diabetes. It's not that they studied all of them. This assumption was made from a sample that was studied, and then they are now generalizing this result on the total population. So that is the beauty of inferential statistics. Okay? Now, so before you can make those assumptions, you must have this understanding. You start with a sample. Okay? But you must understand the population. So there's what we call the theoretical population. So the theoretical population is that population that you truly want to generalize your findings to. So that's the theoretical population. Who do you want to generalize these findings to? Then you now have your study population. That is the population that you can access. That maybe there is a sampling frame, okay, from which you can choose your sample. Okay, so usually the theoretical population and the study population, they are not really too far away from one another to a large extent. Okay, then you now have your sampling frame. Is from the sampling frame, that's the list of the study population that you can sample from, the list that you can sample from, or the frame that you can sample from. And then before you now have your sample. So the goal is to use whatever findings that you have from your sample to be able to generalize it on the theoretical population. Okay, and that is if we can study the whole population, we'll not be talking about statistics. We'll not be having this lecture. Okay, if we can collect all the entities, okay, that have that characteristic that we are trying to measure in common, all of them. So for example, all the adults in Nigeria, if we can get all of them and then get them to do diabetic screening, and then say, okay, these ones are the ones that are positive, and this one that is the one that are negative. We'll not be talking about statistics because you will not need to take a sample. Okay, so we'll just be talking about parameters. Okay, because the parameters are the numbers that describe the characteristic in a population. But once you take a sample, then you will now be talking about statistics. That's when you talk about statistics. Because those are the characteristics in your sample. And then we want to use these statistics to estimate the parameters. That is the goal of inferential statistics. I'm sure that you understand what I'm saying. Estimate the parameters. We want to use statistics to estimate the parameters. So you must understand the concept of estimation. Okay, that's the first concept I want to describe. I want us to discuss now. So the concept of estimation. So there are two forms of estimation. There's what we call the form point estimate and interval estimate. Okay, point estimate and interval estimate. So a single value used to estimate a population parameter to provide the best guess as to what the best guess from the statistics, on the parameter is a point estimate. While a range of values that likely contains the population parameter Sorry, am I still audible? I'm sure my internet is misbehaving here. Can you still hear me?
Yes, you're still audible, sir.
Okay, great.
Yes,
So,
sir.
great. So a range of values
You are no longer audible, sir. You can see your screen, but you're no longer audible, sir. Sorry, can anyone hear the guest speaker? Just to be sure.
We can hear you, sir.
No, we cannot hear him.
All right, thank you very much. I'll just send a message to chat. So we can't hear you, sir. Sorry. Sorry.
Sorry, am I audible now? Sorry, the thing went off.
Yes, you are, sir.
Okay, great. Thank you. Sorry. So we are talking about inferential statistics. And I've told you that we have parameters, we have statistics, and we are trying to estimate the parameters from our statistics. Okay, and that is the goal, that is the beauty of research. And that we have point estimates and we have interval estimates. Okay, so your popular 95% confidence interval is a form of interval estimate. And what does it say? It's a range of values. So if you look at this example now, it said 95 confidence interval is 68.3 to 76.7. So what he's saying is that we are 95% confident that the true population value, which we call the parameter, which I call the parameter, because the parameter is what we want to estimate, that the true population value will be between this 68.3 and 76.7. So if you look at the former example that I gave here, so we got 5.8, but we are saying that the true population value should be that the true population value, that's the parameter now, will be between 4.3 and 7.1. So that's basically the interval estimate. Okay, and how do you, when you are conducting your research, let me not waste time here. When you are conducting your research, you must give us what I normally recommend is that you must give us the point estimate and also the interval estimates. Extremely important. We must have the two, okay, so that we can have an idea that, okay, the range, we expect that the population parameter will be within that range, so we must also have those values, okay? So I've already mentioned what confidence intervals are. It's a defined interval of values that include the statistic of interest by adding and subtracting a specific amount from the computed statistics. So is the probability that the interval computed from the sample data includes the population parameter of interest. I'm sure this is clear, so this is basically what confidence interval is. Because you have to deal a lot with confidence interval, I will just mention one or two or three things about confidence interval. Number one is there are some things that will affect your confidence interval. So again, let me ask a question. When we are talking about confidence interval, which one is better in terms of result that as a researcher you want to see? The one with very short confidence interval, that's there is a very short range between the two values, or the one with long interval? Which one is better? Short interval or long interval? Short range or long range?
Short
Let's
range.
check the chat box. Okay. Olorunfunmi Joshua. Short interval, short range. So is the short interval, okay, great. Richard, short. So you want it to be very short, because if it's short, we can be sure that the value, we know if I say something is, if I say the true value is between 1 and 100, for example. Okay, I say the true value is between 1 and 100. That's one range. And I also and I also say that the true value is between 1 and 4. Which one is better? That the true value is between 1 and 4 is better, of course. That's short. So because I know that I have very few values to deal with in that range, so we are sure that our true value is within 1 and 4. So if it is not 1, it is 2, it is 3 or 4. We don't have more than that. Okay? But if you say the true value is between 1 and 100, so that means you are contending with any number between that range. So a short range is far better. That's why we want to have a confidence interval with short range. So what are the factors that can affect whether your interval will be long range or short range? The level of confidence, of course, that you propose. So if you are, usually we use 95% confidence level, giving room for 5% margin of error. Okay, so that's a standard practice. But in some in some studies, you also see 99%. So in some studies, you see 99%. So let me ask this question. Between 95 and 99, which one will give you a shorter range? Between 95 and 99, which one will give you a shorter range? 95 or 99, which one will give you a shorter range? Since we say a shorter range is better now, which one? Chat box, let's check. Somebody said 99. No. You are saying 99, no. It's 95. Yeah, Richard got it. It's 95 that will give you a shorter range. Because 99, you want to be 99% confident. So it will give you a longer range. Okay? It will give you, because you want to be 99% sure that you have the value, you have the value within that range. You have your true value within that range. So that means it will give you a larger range than 99. And of course, if you pick 90%, that will give you a more shorter range. Okay, but all of that, they have implications. they have implication, they will have implication on, because if you want to be more confident, that means you want the degree of error to be less. So if you are looking at 99, so that means you are looking at 1% degree of error. So in that case, it will also impact on several other things, maybe your sample size, and like I said, this your confidence interval, and so on and so forth. Okay, so that's what this one is saying. So if you look at confidence interval, as you move up, the width of the confidence interval will become broader. Okay, so that's what it's saying here. So if you look at this first figure, that's what it's saying here. And then your data variability will also affect your confidence interval. So I've mentioned the data variability. We all know the meaning of data variability now. So if you have low data variability, you have very good confidence interval. It will be narrow confidence interval. If you have high data variability, if all your data are spread, they are just everywhere, you will have broad confidence interval. So you want to aim for low variability as much as possible, just like we said. Another thing that will affect your confidence interval is your sample size. So if your sample size is large, you will have a good confidence interval. It will be narrow. If your sample size is small, you will have a very broad confidence interval. So these are some of the factors that will affect your confidence interval, which you must take note of. So I will not spend time here. So let's just move away so that at least we have that understanding now. For constructing confidence interval, most of you will be using a statistical package software. So you just ask it to construct it for you. So I believe we have a better understanding of what confidence interval is now, and is an estimate, a measure of estimate, okay, an interval estimate, that we use to generalize, or in inferential statistics, that we use in inferential statistics. But there is another method, okay, that we also use in inferential statistics, which is hypothesis testing, which is what I want to talk about now. So you have confidence interval estimation, and you have hypothesis testing that will give you a kind of point estimate. Now, at the end of your hypothesis testing, what you're going to have is more like your p-value, okay? It's more like a point estimate. Okay, so we've talked about interval estimate. So your hypothesis testing will give you like a point estimate. So let me just keep it like that. So in your work, you are expected to state your hypothesis. Okay, you are expected to state your hypothesis, because every work is either to generate an hypothesis. So at discretists, I'm sure during your research methods, they will have told you that you have some study designs. They will just help you to generate an hypothesis. Okay, while you have some other study designs that will help you to test an hypothesis. Okay, but you can't test an hypothesis if you don't state the hypothesis that you want to test. Okay, so that's why in research, it is expected that you must state your hypothesis. Okay, especially when you are talking about differential statistics. So you have to state your hypothesis. So what is an hypothesis? It's just an idea or a theory that is not tested. Okay, so it's just an assumption that is not, we want to find out whether that theory is true or not. So for example, if I said females smoke more than males, that's an assumption. I've not tested it. That's an hypothesis. Or I want to say female doctors are experiencing more burnout than their male counterparts. Female resident doctors experience more burnout than their male counterparts. That's an hypothesis. So before I can say that statement is true or not, it has to be tested. So any statement that you make, especially when it comes to research, is an hypothesis. So it has to be tested. We want to find out whether it is true or not. Or maybe just from your anecdotal observation, you observe that, okay, more females are complaining of burnout than males. More female resident doctors are complaining of burnout than males. So you think, or maybe from your data, from your initial primary data, secondary data, you just notice that, females are more affected. So, but it has not been tested. That observation may just be due to chance alone. So this is where we talk about hypotheses. We have several types of hypotheses, but we normally talk about two types of hypotheses in medical research or health research. The null hypothesis. Okay. We're having some background noise. Maybe we can mute our mic, except you want to interject me. So the null hypothesis, no difference, no relationship, we're all familiar with that. While the alternative hypothesis, sorry, I'm going to be skipping quite a lot of things because of time, but I want to assume that we're all familiar with some of these things. So the ones that I know I need to spend more time on, I will definitely do that. But the ones that I believe we're all familiar with, I will skip. But if there are questions around them, we'll attend to them. Okay. So what I want to state here is that rejecting the null hypothesis is what provides evidence. That there is an effect, that the alternative hypothesis is true. Okay, so we have the null hypothesis and we have the alternative hypothesis, or the alternate hypothesis, which is the researcher's hypothesis. Okay, so you state the null hypothesis and you state the researcher's hypothesis, which is the alternative or the alternate hypothesis. That's the opposite. So what I want to emphasize here is this. In statistics, our tests are relative to the null hypothesis and not to the alternative hypothesis. This is very important, because in your interpretation, in your conclusion, in everything that you are doing, as far as hypothesis testing is concerned, is about whether to reject the null hypothesis or fail to reject the null hypothesis. That's what you are looking at. So everything is centered around the null, and it's easier to center your argument around the null, because the null is saying there is nothing there. Okay, if you want to center it around, okay, there is something there, you now start having all kinds of questions again. Okay, what is there? How much is what is there? How less is it? Is it blue or red? Is it this or that? So it gets complicated, but it's easier to deal with when we just say there's nothing there. So, and the onus is now on the researcher to prove that there is something there. Okay, and so I normally use this example, like if you pick a criminal, you charge a criminal to court. Until proven otherwise, they will say the guy is not guilty. Okay, they will say the guy is not guilty. So when you charge the person to court, you now have to bring evidence to say whether the person is guilty or not guilty. And when they say, okay, at the end of the day, the person is not guilty, it doesn't mean that the person is innocent. It may just be that you do not have enough evidence to prove that the person is actually guilty. So the same thing with research. So we actually center our focus on the null hypothesis. So how do you go about hypothesis testing? So the first thing is you formulate the hypothesis. You must formulate your hypothesis, both the null and the alternative hypothesis. You must set your significance level. Okay, and that's the level at which you will reject or fail to reject the null hypothesis. That's like your benchmark. Okay, because if there is no benchmark, then we cannot say something is as somebody has passed or somebody has failed. So you have to set your significance level. Usually we set it at 5%. You have to calculate your test statistics. So you have to know which test that is appropriate to test that hypothesis. And we're going to talk about that shortly. Okay, and then you now calculate your p-value and then make decision based on that. Okay, so these are the standard steps in hypothesis testing, which you must all be familiar with. Just to mention that when you are also doing your hypothesis testing, you have to mention whether it is a two-tailed test or a one-tailed test. So let me give you an example. So if I'm saying that the example of burnout that we have mentioned now, that there is no statistical significant difference between the burnout rates among female resident doctors and male resident doctors. Okay, that's a two-tailed test because that is a non-directional test. Non-directional in the sense that I'm not saying one female has higher burnout rate than male or vice versa. Okay, I'm just saying that there is no difference in the burnout rate between male and female. But the moment I introduce greater or lesser, more or less, bigger or smaller, the moment I introduce those concepts into our test, then it becomes a one-tailed test. Okay, this is also important because it will guide everything in your result and also in the interpretation of the results. Okay, so this is extremely important for you to note. And you must also note that there are some errors that we can make, in hypothesis testing. Okay, you also have to note that because at the end of the day, you want to mitigate making all these errors, especially when you are looking at your methodology, you have to factor it into your methodology and things like that. So you can for example, you can make a type 1 error where you reject the null hypothesis when it is actually true. When you fail to reject. Okay, so when you reject the null hypothesis when it is actually true, you make a type 1 error, which is the alpha error. And type 2 error, when you fail to reject the null hypothesis when it is false, you make a type 2 error. Okay, anyway, you can read more about this, but these are some of the errors that you make in hypothesis testing. Now that I've talked about confidence intervals and p-values, which we normally get from our hypothesis testing. So what is the difference? Usually, the p-value is the probability of observing the probability of observing your data, a more extreme data, if the null hypothesis is true. So let me break it down this way. So if you say the p-value is 5%, so the p-value, we normally set the p-value at 5%, and we say, okay, the p-value is less than 5%. Okay, 5% is our benchmark. And the example I normally use is this. So if you say the pass rate is 50%, I'm just giving an example. Now I'm going to use two scenarios just to explain the p-value. So when you see p-value, you don't have to cram anything. You just have that understanding of what exactly it means. So p-value is the probability value. So that's what that p there is probability. Okay. Unfortunately, we can't really go into the probability theories in this lecture because of time. So I just try to focus on areas that I think are very, very important to what you are doing or what you will be doing. Okay, so P there is probability, and then you have value. Okay, and when we say P value of 0.5, for example, is 0.05, that's 5%. The P value is 5%. That's the probability that the null hypothesis, you remember that is null hypothesis that we are dealing with here. I've said everything is centered around null hypothesis. Okay, so when we are doing our hypothesis testing, it's centered around null hypothesis. So, and we want to know whether the null hypothesis is true or not true. Okay, so that's what we want to know. But the focus is actually whether the null hypothesis is true, because that's the focus. So just remember that what we are trying to test is the null hypothesis true? Is the null hypothesis true? Okay? So if you establish that is the null hypothesis true, so we now say the probability that the null hypothesis is true is the p-value. I'm sure you got that. The probability that the null hypothesis is true is the p-value. So p-value is the probability that the null hypothesis is true. Let me just keep it that simple. The probability that the null hypothesis is true is the p-value. So if we set our p-value at 5%, so what we are saying is that once we have evidence to show that there is 5% chance, anything 5% or more chance, or 5% or more probability that the null hypothesis is true, then we will take it that the null hypothesis is actually true. Okay, so that's what we're saying here. Okay, so if I say, so that's our benchmark. 5% is our benchmark. That if null hypothesis scores more than 5%, then we say it's true. Okay, if it scores less, then we say null hypothesis is not true. Then we have to go with the alternative hypothesis. So let's say when we have set 5% as the benchmark, and then we now got 0.04, we now got 0.44%. So put it in the chat box. Are we going to say the null hypothesis is true or not? At 0.04, that's 4%. Yeah, Adepoju, not true, not true. Mutiyat, not true. Olufemi, not true. Thank you. So I think I've got it. So that's not true. So 4% means the null hypothesis is not true. So what are we going to do with the null hypothesis at that level? We're going to reject the null hypothesis. Okay, so we reject the null hypothesis because so when you see in research that say something is significant, when you say it's less than 5%, so it's significant. So what we are saying is that the null hypothesis is not true. So the result is significant. So that's what we are saying. Because once the null hypothesis is true, then the result, because the null hypothesis is the one telling us that it's not significant, that the result is not significant. But once we reject the null hypothesis, then we can say the result is significant. So when you say 0. Less than 0.05, statistically significant, that's what we mean. So the null hypothesis is not true, so the result is significant. If it is more than 5%, so the result, the null hypothesis is true, then the result is not significant. I hope that is clear. And then I've explained confidence interval before. But in the interpretation, I didn't explain the interpretation when we are using it in inferential statistics. Okay, so the interpretation for so if we are just looking at a statistic, does it contain what do you call it? The true value, the true population parameter. Okay, so that's one way of using confidence interval. Okay, but when you now want to look at whether it is statistically significant or not, okay, then you have to now factor in some other, how will I put it now, some other criteria or some other questions. So for example, the confidence, if a 95% confidence interval for a difference exclude a zero, or a confidence interval for a ratio exclude one, the result is statistically significant. Okay, so what is saying here is this: if we're trying to look at the example I gave now, the burnout rates, okay, between female resident doctors versus male resident doctors in LASUTH. Okay, we want to see whether there's any difference in the burnout rates. So let's just work with that example. So at the end of the day, I now find out I computed my confidence interval. And that confidence interval in the range, it includes a zero. In the range, in whatever range that is computed, it includes a zero. Then it's not statistically significant. So that's what you are saying. But if the range excludes a zero, if there is the difference, the range of the difference, there is a difference, yes, between the two, but if the range includes the zero, then it's not significant. If it excludes the zero, that range excludes the zero, maybe from 2 to 4, there is no zero in between, then the result, that difference is statistically significant. So that's how we interpret the confidence interval. That's for a question that relates to difference, maybe difference in means or whatever. But when you are looking at ratio, especially when you are dealing with things like maybe cohort studies, or you are looking at interventional studies and whatever, and you are looking at ratio. So in that case, if it excludes one, then it's statistically significant. If it includes one, then it's not statistically significant. And you know the reason why. When you are dealing with ratio, one, anything one is no difference. So you remember your odd ratio. When your odd ratio is one, or your risk ratio in the cohort study, I'm sure they will have talked about some of those things. Your risk ratio is one, you know that there is no difference between the exposed and the non-exposed. That's what it's saying. But when it's more than one, then that's when you talk about risk. So you remember now. So that's when you talk about risk. So the higher the risk, the higher the number, the higher the risk. Okay, so in that case, if your confidence interval exclude one, then it is statistically significant. If it includes one, then it's not statistically significant. So you need to take note of this in the interpretation of confidence interval. Because of time, how do you know which test to use? How do you choose the right test? That's what I want to talk about now. We've talked about, so most of you guys will see things like chi-square, t-test, regressions. Use regression, don't use correlation. Use correlation, don't use regression. Use chi-square, don't use t-test. They use this, you're not supposed to use this, you're supposed to use that. So how do you know which one to use? Okay, so that's what we want to talk about now. So choosing the right test. So it starts with your question, your research question, that will lead to your methodology before you can start talking about the statistical test that you want to use. So you must first know what are the research questions. So if the research question is so for example, if the research question is to compare means, or it has to do with comparison of means, or to look at relationship between two variables or something like that, that will inform the test that you're going to be using. So let's look at it now. For example, if the research question has to do with association, okay, and when we are talking about association, usually we are talking about association between two variables. Okay, association between two variables. Okay, I mean, generally speaking, if we are not looking at prediction or things like that, so association between or multiple variable analysis, we're not looking at that now. We're just looking at something basic, association between two variables. And these two variables, they are two categorical variables. The test you will use will be chi-square. If the question is to compare means of two variables, okay, compare means of two variables, but these two variables, they are two, the two groups are independent of one another, so they are not matched and they are not related. Okay, so you have two groups. I want to see mean. Anywhere you see mean, they are talking about numerical data. Like I said, so you don't do mean of gender or mean of smoking status. It's mean of numerical data. And then that numerical data, we now want to see the mean in two groups, maybe male and female, young and old, or something like that. Okay, so for example, now if I say, okay, I want to see the burnout rate. So if that burnout rate is a numerical data, for example, between male resident doctors and female resident doctors. So in that case, I'm going to be using what we call an independent t-test. Okay, now if it's the same group, but I'm now doing it two times. So for example, this pre-post test, maybe before this test, before this lecture, we did a pre-test to look at your scores, pre-test. And then after the lecture, the same group, a post-test. So we are doing pre-test at one time, post-test at the other time. And then we are now comparing the average scores between those two times. The test will be peer t-test. Okay, and we have quite a lot of that also in medical research, especially when you are doing trials and things like that, or you are comparing maybe before pregnancy, something, and then after delivery, or during pregnancy or after delivery. So you have several scenarios within the medical healthcare space, for us to explore this type of method. Okay, when you are comparing means, more than two groups, that's three or more groups, just like this second one, we use ANOVA. Okay, when you are comparing mean, okay, three groups or more, but it's the same groups. It's the same group, not three groups, are the same group, but more than two times, three or more times. Okay, so we use another type of ANOVA, which we call repeat measures ANOVA. I don't have it here, so you can take note of that. So repeat measures ANOVA, I missed out that one here. Okay, when you have relationship between two continuous data, okay, maybe age and hypertension, BP and cholesterol, blood sugar and hypertension, we want to see relationship. Then we talk about correlation. If we want to predict an outcome from a continuous data, okay, the outcome variable is continuous data. I want to predict that outcome from several other variables. But now, just one, what do they call it now? Just one outcome, one independent variable. Okay, when I was describing variable, I didn't talk about how they relate with one another, but if there are questions around that, I will take it during question and answer time. So the outcome, we're looking at a continuous variable as an outcome, and we're looking at another variable as an exposure. We're going to be using a linear regression. Okay. If the outcome is binary, okay, binary means just two categories, two options, whether yes or no, alive or death, and things like that. We're going to be using the logistic regression. Okay, and we have several other variables to predict that outcome. We're going to be using logistic regression. So for linear regression, if it is one exposure to one outcome, linear regression. If you have multiple outcomes, multiple exposure, and everything in between, you can have multiple regression. Binary outcome and then several other independent variables, you can have logistic regression. If the outcome is time to status or time to event, okay, so for example, time to death or time to arrival or time to any event, okay, if that is the outcome, then we're going to be using survival analysis. So these are the things that will guide your choice of statistical test.
It's 11 o'clock.
Okay, so now I just put this so that I'll be able to put it more, I'll be able to make it a bit clearer. So the first question, what is your primary research goal? Okay, if it is comparing means between groups, how many groups? Okay, if it is two groups, are those groups independent or paired groups? If it is independent, then you use independent t-test. Now, for all the tests that I talked about, they are for parametric statistics. So what I mean is that those data must follow certain assumptions, including that they must be normally distributed. Okay, so they are for parametric statistics. Okay, so independent t-test. If you cannot use parametric statistics for one, you cannot use independent t-test for one reason or the other, which I'm going to mention some of the reasons, some of the assumptions as we go on. I will just mention some of these tests. And hopefully in the next 10 minutes, should be able to put a wrap to it. You can use independent t-test. Then you have to use the non-parametric option or counterpart of that test, which is Mann-Whitney-U test for independent sample t-test. Now, if it is a paired data, then we talk about paired t-test, which is parametric. If it is not, if it does not meet the assumption of paired t-test, then we have to use the non-parametric counterpart, which is Wilcoxon rank test. We are very limited in time. We may not be able to go into details of everything, but at least you have the foundation, which I believe will be strong enough for you to build on. Now, this is where we branch into these two groups. Now, how many groups? We are still comparing means between groups. How many groups? More than two groups. then that is where you start looking at ANOVA. And then the non-parametric counterpart is Kruskal-Wallis test. Now, this understanding is important. Just having this understanding is important. Even if you don't have the in-depth of what each of these tests, what they mean, but at least having this understanding is extremely important. Your research goal is to investigate relationship or associations. Okay, then what type of variables are you looking at? Two categorical chi-square test or Fisher's exact. I'll talk about when to use that. And then two continuous Pearson's correlation, Spearman correlation, Spearman's right correlation. So that's how to follow that. Your result question is about prediction. Okay, so what is type of outcome are you looking at? Continuous outcome, regression, linear regression, binary outcome, logistic regression. So this is just to make it a bit simple for you so that your research question should guide. Usually in the same research project, you can have questions along all these three parts, okay, which is fine. So it's just to know the first question, this is the statistics that will help us address it. The second question, this is the statistics that will help us to address it. Maybe you have different kind of questions in the same research project, but you must know the statistics that will help you to address it. So the special statistical analysis, I've mentioned the multivariate analysis. That's multiple linear regression, analysis of covariance. The survival analysis, we have Kaplan-Meier's curve and then cost proportional hazard model. If maybe in another time we can look at advanced statistics and then maybe we now focus on those ones. But what I've done with this lecture is to just start with the basic, foundation, so that I do not assume that all of us already have that foundation, and then build it up a bit. But if we need to discuss advanced statistical methods, we can just focus on some of these advanced ones, at later times. So let's look at common statistical tests. Chi-square test can mention test association between categorical variables or goodness of fit. Okay, we have two types. Usually we use chi-test of independence if two tests are related. Fitness if the test frequency match expect if observed frequencies match expected frequency. So usually we use a test of independence. So there are sometimes chi-square test, you have to correct it maybe with Fisher's exact or Yates test. So that's when the expected frequencies is less than 5 in any of the cell. Okay, so when you are conducting your chi-square test, the software will tell you when you have expected frequency less than 5. At that point, you may not be able to use chi-square test. You have to correct it with Fisher's exact or Yates test. So I've given an example here. Testing smoking status is associated with lung cancer diagnosis. This is also an example of when you use chi-square test. I want to see whether vaccination status, is related or has any effect on influenza infection. Okay, so the assumption, the random sampling, independent observation, like we said, expected frequency greater than 5 in at least 80% of the cells, and no cells with expected frequency less than 1. So these are the assumptions that must be met before you use chi-square. If these assumptions are not met, then you have to correct that test. Okay. Independent sample t-test, I've mentioned that you use between two, but I just want to focus on the assumptions. The independent observations, and then it must be normally distributed, and the sample size must be greater than 30. Okay. There must be homogeneity of variance. Okay. So between the two groups, the variance should not be too far away from one another. And you can test that. All this can be done using your statistical package. Okay. So for example, comparing systolic blood pressure between diabetic and non-diabetic, comparing recovery time between two treatment protocols. These are examples of when to use independent sample t-test. So the two groups must be independent, no overlap between the participants. That's what we mean by independent. So peer t-test, they are the same group, but at different times. Okay. The same assumption we also apply here. That's the same assumption for independent sample t-test. We also apply here, except that they are dependent. The groups are dependent. So for example, a pre-treatment, post-treatment measurement, maybe for scores for BP or before and after drug administration, kind of project. So you can see that. So the difference between independent sample t-test and peer t-test is just different participants here, the same participant usually here, except they are matched, two separate groups, two separate conditions or two separate times, and usually between subjects. This is usually within subjects. Okay. We have ANOVA, analysis of variance, compares means across three or more groups. So, and we have different types. I think I measured the repeated measures ANOVA for the same subject multiple times. Okay, so one way, one independent variable, two way, two independent variable. So your independent variable, that's your exposure. Your outcome variable, that is the outcome. I assume that we all understand that. But if there's any question around that, we can treat it later. So example here is comparing effectiveness of three different antihypertensive drugs on reducing blood pressure. So that would be an example here. Multivariate ANOVA. So there's also MANOVA. So the difference between ANOVA in that ANOVA has just one dependent variable. So when you are looking at one dependent variable, so in this case here now, the dependent variable is, so let me ask on the chat box. Here, this ANOVA, this slide that I'm projecting, we are comparing effectiveness of three antihypertensive drugs on reducing blood pressure. So which one is the independent variable here? Put it in the chat box. Which one is the independent variable? Chidinma, antihypertensive drug. Okay, any other answer? Which one is the independent variable? Bolanle, antihypertensive drug. Okay, so you are correct. So we just have, so the independent variable here is the antihypertensive drug, while the dependent variable is the blood pressure. Okay, so now in MANOVA, you have multiple dependent variables. Okay, so you can have blood pressure, you can have blood sugar, so you can have multiple dependent variable. Unlike here where you have just one dependent variable, that's in ANOVA. They both have multiple groups, but this one is multiple variables because they have multiple dependent variables. So example is comparing 3 rehabilitation programs on physical function and quality of life score. So we are comparing one exposure, that's one independent, with the outcome, which is physical function, and then another outcome, quality of life, at the same time. So in this case, the test we have to use is multivariate ANOVA. Okay, we also have analysis of covariance, also kind of related to ANOVA, but this one is when you have one or more continuous covariants. Okay, so we normally use ANCOVA to control for confounding variable, increase statistical power just to reduce the confounding effect of variables. So for example, if we are comparing weight loss across 3 diet interventions while controlling for baseline BMI and age. So at the independent variable level, so you have outcome is the weight loss, okay? So weight loss, but at the other hand, we are looking at diet, but we're not just looking at diet alone. We're now looking at BMI and we are looking at age all at the same time. So in this case, we're going to be using analysis of covariance. Correlation is just between two numerical data. So Pearson's just to look at linear relationship. And then the others, they are more like non-parametric counterparts. Okay. Because of time. Linear regression, I think I've mentioned this, is more like a predictor. So you predict the continuous outcome based on one or more predictors. Okay, so you have one outcome, just one outcome. Okay, but it's a continuous variable. And then you now have one or more predictors. Okay, so you can have linear regression or multiple linear regression. So multiple regression. So when you have more predictors, so that becomes multiple linear regression. When you have just one predictor, that is simple linear regression. Okay, so there are so many other metrics around it, but each of them are topics by themselves, but we do not really have a lot of time here. But if you have questions around them, we can take them. Logistic regression, I've also mentioned it. The outcome is binary. And then you have other predictors. So you have predictors. So you can have more than one predictor, okay, against an outcome that is binary. Okay. And then the statistics is odds ratio. So I think my goal here is just to understand which the statistical options, the statistical tests that are available, and when you should use one, okay, as against another. Okay, not really going so much into the details, and then just have basic understanding of what that statistical test is all about. Okay, because if you really want to go into the details of all of this, those are different lectures by themselves. But maybe from question and answer, we'll be able to address gray areas, around these statistics. There are so many other statistics, so many others, but I think we should just have an idea of what other option, multinomial logistic regression, ordinal logistic regression, Poisson logistic regression, cost proportional hazard regression, that we use in survival analysis. So it's good to have an idea of all of this. Maybe 1 out of 100 people will want to do analysis along this path, okay? And that way they might need, support of a statistician, okay? And then I also mentioned survival analysis. So we have the common methods, Kaplan-Meier, log-rank test, and cost regression. Okay, so when you are doing anything that the outcome is time to event, okay, so, and you want to look at survival rates or survival, the prediction of survival, okay, like, what do you call this thing? Prognosis of something, or you just want to look at predictor of survival, like what are the things that will predict whether somebody will survive a car drive maybe in 2 days or in 1 month or 3 months. When you are looking at those kind of analysis, then you have to run survival analysis. Okay. Data analysis. So this is just talking about some statistical packages. So all of you will use packages to analyze your data. So there are several of them. There are so many. Okay. There are more than 100 actually of different packages. But the commonest ones are the ones that you're all familiar with. Excel, SPSS, Stata, SAS, those ones are they are not free. They are for a fee, where you can have the free ones like EpiInfo, PS, PP, R, and so on and so forth. Okay, so for some of you, I'm sure most people, they are just familiar with SPSS. Most people are just familiar with it. But SPSS, common in healthcare academic research, is user-friendly, quite user-friendly. But when you talk about in terms of robustness, looking at advanced, analysis, and then dealing with enormous data, okay, you want to look at softwares like R, Stata, SAS. Excel should just be complementary, maybe just to collect your data and then run simple descriptive statistics. Okay. For people that are quite interested in learning, there are a lot of materials that can help you learn some of these softwares. And I encourage doctors, researchers to at least have basic understanding of these softwares. So there are a lot of materials online on YouTube that can help you to just be able to navigate your way around some of these softwares. Some of them, the learning curve is tougher, especially for R, Stata, SAS. But for SPSS, it's quite easy to learn because it's point and click. So you just point, click, unlike how that is more of coding, command and all of that. So I think you can just, if you have interest, you can just pick the simple one, maybe SPSS, and learn a bit more about it. For qualitative data, you can also have different tools that can help you. Okay. I'm sure for data collection, for qualitative data analysis. We didn't talk about qualitative data analysis or qualitative data generally, because for biomedical science or biomedical research, we deal a lot more with quantitative research methods. Okay, we use a lot of quantitative research method, not qualitative. So that's why I didn't really say anything about this. So for data analysis, I need to mention this before I round off. I have just 2 slides to go. So, but before I round off, I need to mention this. When you are collecting your data, you must make sure that you have a quality data, because it's garbage in, garbage out. Okay? You check for missing data. You check for outliers. You have to first check that you have a very quality data before you start running your analysis, or before you even send it for analysis. I think that should be your own job. Don't just send any data the way it is, even if you want to get somebody else to analyze it for you. You have to check your data one by one to be sure that you have a lot of consistency. You can check the normality of your key outcome variables to be sure that, okay, you are the ones that, okay, how do you deal with this? How do you deal with that? Just basic, management of your data at the initial stage will make a whole lot of difference. And it's good to capture your data in tools like RedCap, or other repository data storing platforms. Okay, I think in the college and in the hospital, I think it's RedCap. So it's better to use that to really keep your data instead of Excel. Okay. All the other things, around analysis, they are just basic things that I think we all do all the time. So these are my takeaways. You must be clear about the goal of your research. So that's the first thing. The other thing is you must clearly distinguish if the goal is descriptive, just to summarize, or inferential, to generalize, or both. So for most of us, it's usually both. Okay, so but you must know which is which. You must understand your data and your materials. Classify your variables by type. Which ones are quantitative, which ones are qualitative, and the measurement scale. Okay, so you must be clear about the different data. If you have 20 variables, you must be able to typify them. Okay, so there's what they call data dictionary. Okay, so that's where in Excel, that's where you define what each of your variable actually means. So by the time you are collecting your data, you must create a data dictionary where you will have everything spelled out. In fact, is that data dictionary, if you want to give somebody to analyze for you, that you will share with the person, or the person will develop and then you agree on that data dictionary. You must tell the whole story. So you don't just give one part of the statistics without the other. So for example, you don't just give me without the dispersion, the standard deviation, or you just give us median without the interquartile range. So everything must go together. So I've had times to correct or review work, and then you only have that, and then you are now start asking for, okay, where is this? Where is that? Okay, so it's extremely important to take note. You must test your hypothesis systematically, the way we have mentioned. You must look beyond p-values. So you have to also look at the interval estimation, and then, especially the confidence interval that we mentioned. And then try and use the right tools, statistical tests to answer your question. We have talked about that. So you have to be sure which test will go with the question that you are asking. And then lastly, you must prioritize data integrity, the quality of your data, because it's garbage in, garbage out. The quality of your result will be based on the quality of the data. So you must make sure that you have the best quality data possible. Okay, and you must beware of missing data, inconsistent data, and things like that. So if we do this, I think we'll have a better statistical analysis for our health research, and we'll be able to churn out good findings, from our projects. Thank you so much. It's been a long lecture, but I hope we're able to pick one or two things. A lot to discuss, but maybe from the question and answer section, we may be able to clarify one or more things. Thank you.
Wow, wow, wow. That was really wonderful. If I would describe Professor Adeniro's session, I would describe it in three words. It was professorial, it was interactive, it was extensive. Can we just leave maybe an appreciation text in the chat box and we'll say thank you, sir. I think we can all agree that it was interactive. It was an interactive session. It carried us along and it was quite extensive. I'm sure that if we give him more time, he would even go to town. Thank you so much, sir. We can just leave the thank you messages in the chat box. And please, if we have question and answer, we still have our question and answer sessions. There's a pop-up box to the top right corner of the Zoom interface. You will see Q&A. There's about 5 questions there already. Please leave your questions there so it's easier to answer those questions there so that they don't get lost in the chat box. I'm informed that the Secretary of the Association of Resident Doctors, University Teaching Hospital, Shobo, is currently with us. We welcome you, sir. Thank you for joining us. We recognize your presence. Thank you very much. I also mentioned that there's a giveaway, a cash prize. I mentioned that earlier when we started. There's a cash prize for, there was a little question. This is the 4th edition of this program this year. We've had 3 editions, and those 3 editions had different topics. So if you can put in the chat box the topics were addressed in those previous 3 editions in the chronological order, then there's a cash gift available courtesy of the editorial unit. So please be encouraged to participate. That being said, before our question and answer session, and we crave the indulgence of our speaker, we have, and also our listeners, we have a quick advert session from Foch Estate. We have the representative with us, Mr. Matthew Cadbury, who will just briefly address us on what they have to offer us. Please, you have the floor, sir. Foch representative, please, Mr. Matthew Okagbari. Please, can you can we have the representative of Foch Estate? Please have the floor. Let's quickly have your session with us. Mr. Matthew Okagbari, are you on the call, please? Pending the time when the Foch representative comes up, please let's keep leaving.
Good morning.
Let's leave our questions and please can you hold on, sir? Let's leave our question and answers. Our questions in the question and answer box into the right top right corner of the Zoom interface. All right, so let's have Foch Estates representative. You have the floor, sir.
Okay. Good morning, everyone. I think I should show my face. Good morning, everyone. Let me share my screen. Okay. Can everyone see my screen? Hello?
Yes, we can see your
We
screen,
can.
please.
Okay. So yeah, and good day everyone. My name is Ovirogene Matthew Okagbari. I'm the founder of Fushare State. And today I want to share something simple but powerful. And this is the same secrets that ordinary Nigerians use to build extraordinary wealth. I'm not here to overwhelm you, just to show you practical strategies that you can use even with your busy schedule as doctors. Now, the wealth in reality. Let's start with the truth. In Nigeria, the biggest difference between people who stay financially stable and people who struggle is the kind of assets they own. Salary, no matter how good, is for survival, but assets, especially land, are for wealth. Most wealthy Nigerians didn't start with millions. They started by buying land early and letting time work for them. So now, why land creates wealth? Land is one of the smartest investments because it always appreciates. Land today will never be cheaper tomorrow. Secondly, it beats inflation. Money loses value, land gains value. Thirdly, it requires no maintenance. It just appreciates just by existing. Fourthly, it offers multiple income options: rent, resale, development. And it's the strongest generational wealth assets. You can pass it down safely. This is how ordinary Nigerians, become extraordinary by buying land quietly and watching it grow. Well, I've heard of several stories. Some of you would have heard of that, where they always say, oh, a land that I bought in 2000 for 500,000 naira is now going for 200 million naira today. So many stories. We've seen lots of developments. We see places in Arepo, places in Magboro, places that people bought for, close to nothing as at that time, appreciate massively. So I'm sure that is not a new development or new story. I'm pretty sure that a lot of you must have heard about that. So now, the smart strategy. Wealthy people follow a smart strategy. They buy early and they buy consistently and they buy in growth corridors before the crowd enters. You see that timing, entering early, that's where the biggest money is made. Now, the opportunity, Ayuturu. Now, let's talk about the real opportunity right now. Ayuturu is in Ogun State and is one of the fastest growing corridors around Lagos. Ayuturu is just 3 minutes from the redemption camp, and it has a lot of development that is springing up there left and right. Lagos expansion is moving towards that axis. Development is rising and demand is increasing. Ayutoro is the home of New City University. It has a private university that's just springing up and they are already looking for hostel opportunities. Now, you would agree with me that any place that has a school would definitely have need for rental accommodations and everything. And also close to the Ayutthaya is also Christopher University. Now, in Ayutthaya currently, a 2 bedroom, currently as we speak, is going for 600,000 naira. People are looking for accommodation. So you buying land and building a 2 bedroom flat, a 3 bedroom, a room and parlor, you already know that you are going to get people who are going to rent it at good money. Then, one thing about Ayutthaya is that it is peaceful, it's affordable, and is strategically positioned, which is perfect for future homes, rentals, or land banking. Now, I introduce Ayutthaya Phase 1, Phase 3, and Phase 4. Now you wonder why is Phase 2 not there? Well, Phase 2 is not there because Phase 2 is sold out. And we have one of you that keen to our properties in the Phase 2 before it's sold out. Dr. Joy, and after she saw the opportunity, she saw what we're made of. she said that I should come and talk to you. And yeah. So you'd ask me like, what is my goal? And my goal is very simple, which is to give young professionals a clean, verified, and affordable way to enter real estate without stress. The documentation is clear, the environment is fast appreciating, and clients are already building. In our phase one, we have a plot available in our phase one. That's the last plot available for now. There's already lights in the estate. People are living there, and it is just 5 minutes from the expressway. And it is a good fit for anyone who is looking to buy and build immediately. So now, why does Foch Estate fit doctors? I understand how demanding your career is. Your time is limited, your schedule is tight, and financial decisions require clarity. So we at Foch Estates, specifically to suit you, we have we tailor our offers in a way that it will be able to make your entrance to real estate very easy. We have flexible payment plans, early bird pricing, low initial deposits, assisted documentation, and inspection that fits your shift times. So now you can focus on saving lives while we make your investment easy. So why invest now? The best time to enter this opportunity is now. People are already building, prices are rising, and as the area develops further, the cost will keep going up. Right now, you are still getting in at a very good level before the next price jump. Now, Ayatori is along the axis of redemption camp. And if you go and ask for the prices of redemption camp, you see that properties are going as high as 40 million. Some places are going as high as, in fact, in Arepo now, to get a land now will be like 40 million, and even when you get to Asheshe, the price is there, you'll be hearing like 20 million. You understand? So these are, if I in Magboro, say if you go to Magboro, the prices just keep on building. And these are places that, as at 6 years ago, if they tell you that you should come and buy this place, some people will be squeezing face. But now the place is a hot cake. You have already missed that one. There's no bother, there's no need going back. But right now, Ayetoro is a place that is still very, 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 very early. It's still like you can still get in right now and still get a good price. So here's my advice. You need to start now. You don't need a huge amount. You just need to take the first step. You can secure your plot with an initial deposit, and we can schedule your inspection at your convenience, and will guide you through the entire process. Foch Estate is not just about selling land. We are helping young professionals build extraordinary wealth, one smart decision at a time. Thank you. And I'll be open to get all your questions.
Thank you very much, Mr. Okagbari, from Foch Real Estate. I think it is without further say that doctors need to indeed take responsibility for their financial future. Real estate is one of the well-established and trusted means. So please, we can leave our emails in the chat box. Show Foch Real Estate and send a well-detailed proposal or information to our email. So just leave your email in the chat box so that you can send those information. Thank you very much, Mr. Kagbari, once again for your time. I'm sure that a couple of you will reach out. Thank you very much. So please let's leave our email in the chat box so that Mr. Kagbari have access to it and send us information. Okay, all right. So we'll then proceed to our Q&A session. Professor Adeniran, sir, we have a couple of questions in the chat box already. Sorry, Mr. Kagbari, please can you take down your slide? Thank you very much.
Okay, yeah.
We have, thank you very much. Professor Adeniran, sir, we have a couple of questions in the chat box, in
Yeah.
Q&A chat box to the right corner. I don't know if you can see them, sir.
Okay, I'm trying to.
Or maybe I read them out.
Okay, please, if you can help me, since you are the main admin.
All right, sir. All right, sir. The first question says, how do we plot IQR, sir?
Okay, yeah. So IQR is interquartile range, and that's the range between the first quantile and the third quantile. So it's not a plot, it's a number. It's just like if you talk about range. So if we have a range, so I'm just using an example now, from 1 to 100. Okay, so if you have 1 to 100, okay, and then at the range normally is the minimum value to minus or to the maximum value. So the maximum value minus the minimum value. So that's the range. That's normal range. That's the usual range that we are. But we now have interquartile range, which is the third quantile. So the value at the third quantile minus the value at the first quantile will be the interquartile range. Now, so that will give you a measure of dispersion for your median. Okay, so you are not plotting it, it's a number. And if you are using a statistical package, it's just for you to ask it to give you, and it will be part of the output that you can now report.
Okay, thank you, sir. Second question says, what is the recommended statistical software that we can use, and do we have any free one?
Okay, I think I mentioned in the presentation that if you are it depends on what you are looking at. If you are looking at the ease of use, user friendliness, SPSS is popular, it's good, it's common, it's easy to use. The only thing is it's not free. So you have to pay for it. In Computer Village or in our ICT, I don't know, maybe they have some cracked version or so, things like that, that you have to get installed and all of that. So it's not free. If you are looking for the free one, it's either you use EpiInfo or R, like I mentioned. But that will take some time. You have to know how to use it. It's not as easy as SPS. So you have to now go for training on how to use it, both for EpiInfo and R software.
Okay, thank you, sir. The next question says that to measure the association between two numerical variables, what test would we use to
To measure
assess the
the
association between two
association between two
numerical variables?
numerical
What
variables.
test? Yes, sir.
Okay, so if you just want to look at the relationship between two numerical variables, so that's a correlation analysis. So one can just use a simple Pearson's correlation coefficient analysis to do that. So just basic relationship between two numerical variable. So correlation will do that.
Thank you, sir. Next question says, what is the difference between descriptive cross-sectional study design and analytical cross-sectional study design?
Yeah, because of course, it's actually beyond the scope of this lecture. But let me just give you one or two hints to know the difference. So for descriptive study, usually maybe just two things. You use it to generate hypotheses. Okay, so that's the first level of study that you conduct just to be able to generate an hypothesis. For analytical studies, we use it to test hypotheses. The second difference majorly is that for descriptive study, it's usually one group. So you just have one group, one in terms of study group, it's just one. For analytical studies, you usually have more than one group. So that's just the major difference. You have now when you are now looking at the different types of analytical or the different types of descriptive, then you can now start going into much details. But just to know the difference key, uh, one is to generate hypothesis, one is to test hypothesis. The other one is usually just one group of people, while on the other side you have much one or two or more groups.
Thank you, sir. The next question says, the person didn't get the analytical method that we can use for quality of life. Perhaps you mentioned enough multivariate, but the person wasn't clear on that. So he wants to know the analytical method we can use for quality of life, sir.
For what?
Quality of life, sir.
Maybe I don't understand the question. If we want to, so is the outcome variable is quality of life? And then what are you trying to test or what are you trying to do?
Okay, I would ask whoever asked the question to please rephrase the
Well, the
question.
person can unmute and then speak, or they can rephrase the question because it's not, I think, I don't understand. I don't
Okay,
understand.
Prof has given us the liberty to please, if you can unmute, just ask the question directly, or if you feel more comfortable in phrasing and typing it in the Q&A box, please do so. Can you unmute? Okay, so I think the person will type it, sir, and rephrase. Okay, next question says to please describe the interquartile range, sir.
Yeah, I think we just did that.
All right, sir. All right, sir. Then the next question says, must every research have a hypothesis?
Yeah, I mean, at your level, yes. I mean, if it is even at undergraduate level, we always want them to go beyond just descriptive statistics and to make some inferences so that the research must have some kind of external validity. So every research work that you'll be doing at your level must have that. And so you must have an hypothesis. You have to conduct hypothesis testing in it and be able to, see how you can generalize your finding to the study population.
Thank you, sir. Next question, what influences where you set your confidence interval either 95% or 99%?
Yeah, so of course, that's a good question. Conventionally, so if you check most research work, we normally set our statistical significant level at 5%. Okay, so if we set our statistical significant level at 5%, so that means we are setting our confidence interval level at confidence level at 95%. So conventionally, generally, that's what you say. But in some clinical trials, especially when you are looking at vaccine trials and the rest, they normally set their significant level at 1%. So that means the confidence level will now be 99%. And the reason why they do that is, of course, because they want to have very, very, very low margin of error. Okay, especially when you are trying to propose that maybe a new drug or to change drug that people are already using and all of that. So for most clinical trials, yes, they normally want to push the confidence level higher. But generally speaking, conventionally, 95% is what most people work with.
Thank you, sir. Next question says, thank you, sir. You talked about cleaning up your data. How do you do that without tampering with the data?
And so when we say clean up the data, what we are saying is, one, there are some missing data. So maybe as a result of non-response, or it was not inputted for one reason or the other. So you have to know those ones. Then you now decide how do you want to manage the missing data. There are some that they are wrong information, they are not consistent. So for example, if you have somewhere they say, okay, male or female, and they said male, and then they said parity, and the person is now say, they now said last pregnancy or something that is related to female, and then there is now an answer there. So that's an inconsistent data. That data is not correct. There's something wrong with that information, because you can't be a male and then be pregnant down the line. Okay, so when we say clean up data is to make sure that the data that you have is representative, is quality, is true of what is being measured. So that's what we mean. It's not that, or maybe I don't understand the question, but when we say clean up data, it should not affect the integrity of the data. It should improve the integrity of the data.
All right, sir. We have one more question, and that says that what is the implication of the very low prevalence of the outcome of interest in the study sample on the statistical significance of covariates during logistic regression?
Sorry, I didn't get that. Please take it again.
Right, sir. What is the implication
Okay.
of a very low prevalence of the outcome of interest in the study sample on the statistical significance of covariates during logistic regression?
Sorry, I don't understand that question, because it's talking about prevalence and it's talking about logistic regression. Please, if
Sorry,
that
Dr.
person can
Kalada
unmute and
Richard.
ask that question so that I'll be able to get the question properly. It's talking about low prevalence, the impact of low.
May I speak, sir?
Okay, go ahead.
Okay, so the question, thank you very much, sir, once again for the very lucid presentation and empowering. So the question is about, okay, the prevalence of compared to what is known turned out to be very low, okay, in my study. And as a result, when the risk factors, the predictors of that particular outcome are being imputed into the multiple logistic regression, what ordinarily from literature and from other studies were found to be significant happen to be not statistically significant in my study. So I wanted to find out what might have been is it possible that the low prevalence of the outcome of interest in my study has had an impact on the results that are coming out from the logistic? Yeah.
Okay, I think I understand you better now. Yeah, so when we talk about low prevalence, maybe the way I will look at it is low yield. So if you have a very low sample size, okay, it will have an effect on the yield that you have. Okay, the yield that you will get. So, and then that, of course, that low sample size will also have an impact on every other, whether all the other bivariate analysis that you will do, and even the multivariate analysis that you will do, including logistic regression. So we have to look at your sample size.
So the sample size is sufficient compared to, based on the formula and compared to other studies, about 410. But the outcome of interest, the dependent variable, the prevalence was
So if the prevalence is just low, and
yeah,
that is true, okay, you now want to see what are the predictors of that outcome.
yeah,
So it shouldn't be an issue. It's not because of the low prevalence. If there is an association, maybe before you move on to logistic regression, you have to first do your bivariate
bivariate.
analysis
Yeah.
to see whether there is an association between those independent variables and your outcome. And then before you now move them into the logistic regression model. So if they are significant at that level, and then you now move them to the logistic regression model, and they now don't have an impact, then that's the result.
It's
So it's
okay.
not because of the low prevalence, actually.
Okay. Thank you, sir.
All right.
Thank you, sir. Because of our time, we'll just take the last question by Dr. Olatunji Gopala. I think it's better you ask this question directly so that all is clear on the question. Dr. Olatunji Gopala, please unmute and ask your question directly.
Okay, thank you very much, sir. We appreciate the lecture you have given us, sir. But I seem to be confused about the 95 percentile, 95% confidence interval and 99% confidence interval. Initially during the lecture, you asked the question that which is better, which will give us a better precision, 95% or 99. Eventually we concluded on 95, even though then I still did not understand. Then when another question came up now, and the person was asking what determines whether we use 95 or 99. You said in vaccine research they use 99% because it gives them a lower margin of error. So I seem to be confused about it. Maybe I've not gotten it very well. I want you to expatiate more on it,
Okay.
sir. Thank you.
All right. Yeah, it can actually be confusing if we are trying to juggle a whole lot of things together at the same time. But let me just keep it a bit simple. When we are talking about precision, or we are talking about the narrowness or the broadness of confidence interval, when I told you that the confidence interval is the interval that will contain the true parameter, the truth that we are looking for is in that confidence interval. So that truth, when is narrow, when the range is narrow, is better. Sorry, I was locked out. Am I audible now?
Yes, you're audible now, sir.
Okay, great. So like I was saying, if the interval is narrow, okay, in terms of so if the interval is narrow, we are more likely going to be able to, the precision is better. That whatever figure that we are picking is just like the example I gave. If I'm to pick a number between 1 and 5, okay, and that number will contain the truth, because it's a narrow range. Even if I pick 3, I pick 2, it will still not be far away from the truth. Okay, I hope you understand that. Because the truth is between 1 and 5. So whatever number I pick within 1 and 5 will still not be far away from the truth. It will still be a representative, true representative of the truth. Okay, unlike 1 and 100, I say I'm supposed to pick 1 and 100. So it will be difficult for number I pick is still going to be a bit far away from the truth because the range is already very high. So that in that context, if I want to be able to have a narrow confidence interval, now listen, it's not just the 95%, the significant level that determines the confidence interval, whether it's narrow or not. You know, I mentioned several factors. Your sample size and this were also there. Sample size variability of your data, they are also factors. But in that case, if I say I want to pick 95, between 95 and 99, 95 will be better. Because at that level, it will give me a narrower range compared to 99. Now, this is what you need to understand. By picking 95, that means I'm saying I want to give allowance for 5% error of margin. So, and that will also have an impact on my sample size. Okay, that will have an impact on my sample size. That means I have to now also, it will impact my sample size by getting more. It will increase my sample size. Compared to 99, if I'm looking at, so if I'm looking at 99% margin of error, so I'm looking at 1%, 99% confidence level. So I'm looking at 1% margin of error. If I'm looking at 95% confidence level, I'm looking at 5% margin of error. So in the context of narrowness of confidence interval, 95% will give us a better precision compared to 99%. Now, it now says that when should we pick 99%? You know, when we are looking at what do you call it now? And I said when we are looking at
Vaccine research, sir.
Vaccine research. Yeah, thank you. Clinical trials. That's what I wanted to remember. When we are looking at clinical trials or field trials or all those trials, vaccine trials. Now, when you are looking at that, you want a higher confidence level that will have implication on your margin of error. So you have lower margin of error. Okay, but again, your interval, of course, will be larger compared to if you have what do you call it, 95%, like we said. It will be larger so the reason why it's larger is this, or the reason, so the reason why it's larger is because for every, so in statistical analysis, for every decision you make on this side, it will have impact on the other side. So I want to be more sure. Okay, I want to be more sure of what I'm doing, of my results. So that means you have to give me, so to be more sure, so that will increase the interval. So that will increase the interval. I want the true picture. I want the true picture to be captured. So that's the word. I want the true value to be captured in the range. Okay, so, and I want to be 99% sure that is captured in the range. 99%. It will automatically widen the range. Okay, I want to be 90% sure. So the probability of being sure is reduced. It will narrow the range. So it's give and take. Once if you increase your confidence level, you want to reduce your error, your margin of error, that means you have to increase your sample size. Number one must increase. It will increase your sample size automatically. That's number one. It will have an impact on your sample size. It will also have an impact on your interval. Okay, so that 99% confident doesn't mean that it's because the way you are looking, the way you are putting it is as if it's like it's talking about the precision. It's not talking about the precision. It's talking about our confidence that the value that we are looking at is in that range. And if I say I want to be 99% sure, certain that that value will be in that range, then that range will automatically be wider. Okay? Because the probability has increased. So the range will be wider. I don't know, maybe it's clearer, or maybe you need, maybe if you need further clarifications, specific clarification on what I've said.
Yes, sir, it's clearer
So
now,
maybe
sir.
if
Because for vaccine
you
research, the
recap,
margin
yeah.
of error is lesser. Yes, sir.
Okay.
I understand better now. Thanks for the clarification, sir.
All right.
All right, thank you very much, Prof. Sir. We appreciate you for your time and for going to town with all of these questions and presentation itself. We say a very big thank you. People have left thank you messages in the chat box for you, sir. So thank you very much, sir. We appreciate you. God bless you, sir. And we hope that if we call on you in the future for more topics and research, that you would back on our call. Thank you very much. And to
Thank
the
you so
LD,
much, everyone, for your time. I know statistics can be a bit dicey, but if we just keep looking at it, keep asking questions, I'm sure it's going to get better. And I'm also happy that we have some of our residents from the community health departments also on the call. So they also, at an advantage, so we can also liaise, interact with them to, to exchange ideas and all of that. I mean, they are better positioned when it comes to some of these things. But don't go in ignorance. Okay? Don't just do things in ignorance, and then you're going to waste time that way. So if you are submitting your proposal, for example, make sure that you have crossed all the T's and dot all your I's. So it's always good to check with one or two people to help you review, especially those that have understanding of statistics. And thank you, Dr. Obasoya, also for introducing it at the beginning. I failed to acknowledge it. So thank you, everyone. Have a wonderful afternoon.
thank you, sir, for the fatherly advice once again. LASUTH-ARD members, please go to the LASUTH WhatsApp page and share good news of what you have learned today. Let's appreciate the excellent schools, the Editorial board. Let's just share and appreciate them on the group chat. All right, without further ado, for our giveaway, we have a winner. Dr. Asumo Salaudin is our winner. The answer is the most comprehensive for all the responses we got. So please send your account details to the editor, Dr. Joy, so that you can be richly rewarded for winning the giveaway. Thank you very much for participating. People have been asking if recordings will be made available. Yes, recordings will be made available for the sessions. So as we bring this to a close, we want to make a special announcement on the Nigerian Journal of Clinical Medicine, which is a publication of the Association of Resident Doctors, Lagos State University Teaching Hospital, Ikeja. We're unveiling the latest issue of this journal, which will be launched and unveiled at the 2025 AGM and Scientific Conference of LASUTH-ARD next week, Wednesday, 17th December. I think that deserves a round of applause. So don't miss out. We save the date. The issue is more than just a journal. It's your key to staying at the forefront of clinical excellence. So stay informed, stay inspired, stay ahead with the NJCM, the Nigerian Journal of Clinical Medicine, the publication of ARD LASUTH. This announcement is courtesy of the editorial board, LASUTH-ARD. Now, we want to give a vote of thanks to say thank you to every one of us who joined in Thank you for your time. Thank you for your presence. Thank you for your participation, for your questions, for your interaction. We honor and celebrate every member of LASUTH-ARD, and we hope that in consecutive editorial meetings and even other association meetings, we will equally turn up and be active and present. Thank you very much once again. I don't know if the president of the association or the editor has a final word before we bring the meeting to an end. Madam President, any final words?
Thank you, everyone. Thank you, Dr. Fashional, for anchoring. Thank you to every Nadite and every LASUTH-ARD present here.
Thank you, Madam Editor. Can we celebrate Madam Editor and the entire editorial team for putting this together and for the consistency they have put through this year. This is the 4th edition. We say thank you, Madam Editor, and the entire editorial team. Madam President, do you have a final word as we close?
Thank
Okay.
you very much, Dr. Fashional. First of all, let me even appreciate you as well for doing an excellent job in convening this academic research forum 4th quarter. And again, to appreciate every single person that joined in on the call, starting with our DCSC, our esteemed guest speaker, the ECLAT executive, the editorial team, and all hardworking members of LASUTH-ARD. Thank you all and have a blessed week. Good night.
Thank you very much, Madam President. Let's all have a lovely day. Thank you and goodbye.
Thank you, sir.